Hi Kelso Public School.
I'm Lisa. I'm a scientist at the Centenary Institute.
And my name's Mim, and today we're going to be doing some really cool experiments. So we're going to be doing lots of chemical reactions. So that means when you get one thing and mix it with something else, and then it makes a reaction happen. So it might explode, or it might get really big, or make steam, or something like that. So we're going to do that and see what happens.
The first one we're going to do is the foamy fountain, or it's also called elephant's toothpaste. The first thing we're going to do is put this hydrogen peroxide into here. Peroxide's the thing sometimes people use to make their hair blonde. So I'm going to pour a little bit into here. Alright, now Mim, what colour should we put in?
Let's put in the blue one.
Okay.
Alright, you ready?
Yeah, put some drops of blue in there. Okay.
Ooh. Gonna give that a little swirl.
That's pretty.
And I'm pretty sure it needs a bit of soap too.
How much do you think it needs?
Just a tiny bit.
Okay. This much? Or a bit more?
Yeah.
Okay, let's try this.
Well, I'm gonna give it a swirl too.
And let's give it a mix. That looks nice.
It does. And so what we're doing next is getting some yeast. So this is what people use to make bread and things like that. And then we're going to mix it in this warm water.
Not cold. That looks good.
Give that a little mix too. And then that needs to sit for about 30 seconds. So we'll just wait. And now here comes the fun part where we're going to add one of these into the other. But before we do, you have to put on your goggles just in case. Alright, I'm ready.
Okay, I'm ready too. Now, let's see what happens.
Oh, very good.
Something's happening!
Oh, cool! I think we need to
Very cool!
Oh,
Wow!
It really looks like toothpaste. So the foam that we made today is really special because each little bubble has oxygen in it. So when we poured the yeast into here, it made all the oxygen in the peroxide disappear really quickly. And that's why it bubbled up so quickly. It also got really hot. Do you know why that is?
Well, Mim, I think it's because this is an exothermic reaction, which means it generates heat.
This is just made with soap and water and yeast, so it's really easy to clean up. So maybe you guys could even do it at school today. Hi guys, so now we're going to do our second experiment, which is called Blobs in a bottle. And all you need for this one is some water, some vegetable oil, and some tablets that will dissolve in water, like aspirin or Barocca would be fine as well. And then we've got some colour as well to make it look really cool.
Yeah.
So the first thing we're going to do is pour about a quarter of the way up of water in here.
Okay. To about here?
Looks good.
Yep.
And now we're going to do the oil. So this is just normal vegetable oil. And you're going to fill it all the way to the top. So you might notice that the oil is staying separate from the water. You know why this is happening?
I think it's because the water is more dense than the oil, so the oil floats on top.
That's right.
Okay, now let's add some food colouring. Mim, what colour would you like to do?
Let's do red this time.
Okay.
Okay, so we'll put a couple of drops in. This will take a little while for it to sink down to the bottom. You need to wait for it to hit the water.
Yeah.
So let's just wait a second. Okay, now I'm going to add the fizzy tablets. Oh, so can you see the red
cool.
bubbles are rising in there like a little lava lamp? So what's happening is those tablets make a gas, and the gas will rise to the top and it brings the water with it. But then when the gas gets to the top, it escapes out of the top of the bottle, and so the red food colouring in the water will sink back down because it's denser than the oil. Now I'm going to put in 5 tablets just to see what happens.
Oh, uh-oh.
Ah, it's going to bubble over!
So for this, we need milk, whole milk, make sure it's not skim milk. We need dishwashing liquid, and we need food colouring.
So what you can see here is the milk in the tray. And now we'll just put some food colouring drops in there. And then when we add the detergent, let's see what happens.
And look, you can see the food dye trying to escape away from the dishwashing liquid.
And that happens because dishwashing liquid tries to break down the fats in things. Now this is usually fats that you find on your plates from the food you eat, but whole milk has a lot of fat in it too. So when we put in the dishwashing liquid, we can see the fats breaking down, and the colour shows us how that's happening.
Hey guys, follow me. We're going to do something fun with tonic water. You know that some things naturally glow in the dark, but you can't see it unless you've got a black light.
As you can see here, Lisa just has a normal bottle of tonic water. And now we're just going to pour it into this beaker, turn off the lights, and turn on the black light. Everything is made up of different combinations of chemicals. Because of all the different combinations, they either absorb or reflect different kinds of light. In a rainbow, you can see all the different colours in the spectrum of light. The combinations of chemicals in tonic water reflects blue light, but you can't see it, unless you've got a dark room and a black light, just like you can't see the stars during the daytime.
Thanks so much for watching, guys. We hope you learned something about science and chemical reactions.
And also a big thank you to your school for having us Suit Up for Science Day. You're helping us raise funds and raise awareness for all the research we're doing here. And without you and your help, we wouldn't be able to keep fighting cancer and other chronic illnesses. Thanks for suiting up for science!
Bye!